Okay, so this is Math-7 factoring on page 413 in your packet. Now, I need to stress that we are using a different method than what your packet describes. We're not using algebra tiles here to talk about factoring. Instead, we're going to use a generic rectangle, just like how we did it the day before. Okay, so this is mainly a review. Okay, so pay attention. Now, number one, we have 4x plus 6. So 4x plus 6, the first question you want to ask yourself is, what is the GCF of 4 and 6? So what is the greatest common factor of 4 and 6? What is the biggest number that can go into both 4 and 6? Well, you only have one choice. So the GCF of 4 and 6 is 2. Okay, so now in this generic rectangle, you divide it into two parts. The first box, you're going to write down 4x, and then the second box is 6. Here, what it represents is the area of this whole rectangle is 4x plus 6, and you need to figure out the dimensions, the length and the width of this rectangle. Okay, so if the GCF of 4 and 6 is 2, that means 4x is 2 times 2x, right? And then 6, positive 6 is 2 times what? 2 times 3. So on one side here, you can write down 2. And then, since I said 4x is 2 times 2x, so that means the top part, this side here, is going to be 2x. So 2x. And then the other side of this rectangle, this part is 6. The area is 6. And if one side here, if this is 2, then this side has to be 3 in order for you to make 6. So this is 3, and you need positive 3 to make a positive 6 here when you multiply it by positive 2. So this is the result of your factoring. 4x plus 6 is 2 times 2x plus 3. So let's write down the answer. 2 times 2x plus 3. And when you look back at this rectangle, (4x plus 6 here represent the area of the rectangle. And then 2 here is your width. And 2x plus 3 is the length. Okay, so factoring is like using the distributive property, but you're doing it backward to figure out the original length and width of a rectangle. Okay, so let's look at the next example. This is number 3. You have 3x plus 12. And remember earlier I said this is the area. So I'm going to put 3x here and then plus 12 here. 3x plus 12, this expression is the area of this generic rectangle, and you're going to find the length and the width, and that is factoring. Okay, so you start asking yourself, what is the greatest common factor of 3 and 12? So what number can go into both 3 and 12? And it is 3, because 3 times 4 gives you 3 times 1 gives you 3, 3 times 4 gives you 12. 3 is the biggest number that can go into both 3 and 12. Okay, so 3x comes from 3 times x. And then 12 here, if you have to use 3 as one of the factor, then it has to be 3 times 4. Okay, so that means the width of this rectangle is 3, and then the length is x plus 4. And then when you check your answer, 3 times x gives you 3x. 3 times 4 here gives you 12. Okay, so the answer here, you factor 3x plus 12, and you get 3 times x plus 4. Okay, so this time I'm going to use the distributive property to check my answer. You always want to check. So I do 3 times x, and then I do 3 times 4. So 3 times x gives me 3x, and 3 times 4 gives me 12. So I have my original expression back, 3x plus 12. Okay, that it checks out, so which means this is the correct answer. Okay, so let's look at the next example. Okay, so this example is number, actually I don't think it's number 3, it should have been number 5. I had a typo here. Okay, so this is 3x minus 9. 3x minus 9 is the area of the rectangle that you have here, and you're going to find the width and the length of this rectangle. Okay, so find the GCF. Okay, greatest common factor of 3 and 9. Greatest common factor is going to be 3. 3 times 3 gives you 3. 3 times 1 gives you 3. 3 times 3 gives you 9. And then 3, to get 3x, you have to do 3 times x. And now to get negative 9, if you use a positive 3, then you will multiply negative 3 in order to get negative 9. Okay, so one side here is 3. And then the length of this rectangle is x and minus 3. Okay, so this is our answer. The dimensions of this generic rectangle is 3 times x minus 3. And remember, you always want to check your answer. So let's check that. So if I do 3 times x, and then I do 3 times negative 3, okay, 3 times x will give me 3x, and then plus 3 times negative 3 is negative 9. Okay, that doesn't look quite like the original expression because we still need to simplify it. So minus negative 9 is the same, plus negative 9 is the same as minus 9. So this is 3x minus 9, which is exactly the same as the original expression. Okay, so this is your answer then. Everything checks out. Okay, so it does take a little bit to get used to doing it this way, but I feel that this is the most effective way of factoring, at least at the beginning. Okay, so that's that. If you have questions, make sure you ask.